Wonder that why loading dose of some of the drugs like digoxin, theophylline, azithromycin, vancomycin is given as double as compared to their maintenance dose. Well, if you have ever dared to think about it, then I am here to answer that question. Well, there are two bases to answer this question. Number one, the theory base, and number two is the mathematical. So first of all, let's talk about the theory of giving the loading dose as double of the maintenance dose. So here is a list of the drugs. It includes digoxin, theophylline, vancomycin, lithium, and two or more drugs. So what is the reason, theoretically speaking? Well, if you see something common in these drugs is their loading dose, their narrow therapeutic index nature, and their dose related or the serum concentration related toxicities. So we have to be very cautious about these factors. So first of all, let's talk about VD. VD is actually the apparent volume of distribution in which the drug has to distribute itself within the body. So if VD of a drug is so much high, it means it has to distribute itself. High concentration of the drug is needed to overcome that VD or overcome that volume of distribution. So in case of digoxin, vancomycin, lithium, and theophylline, uh, volume of distribution values there. And now I'm putting the reference of the Lippincott pharmacology. In the Lippincott pharmacology, if the volume of distribution of any drug is more than 42 liters per 70 kg, means for the normal human being, then the drug has to distribute itself in the total volume of the body fluids. It includes your extracellular fluid, your intracellular fluid, your blood. So drug has to distribute throughout these compartments or these fluids. So when drug covers that volume of distribution, now the things come that how the therapeutic effect will be achieved, because therapeutic effect is actually linked with the specific target inside the body. It could be intracellular, it could be extracellular, or it could be inside the blood. So drug has been distributed. Now very less amount of the drug is available to cause the therapeutic action. So to achieve the therapeutic action, we have to give a loading dose. It could be double, it could be triple, or it could be the single, means it could be equal to the maintenance dose. Now on which basis we have to decide that the loading dose should be the double of the maintenance dose? That is actually the mathematical point of view. Now we have to see the mathematical point of view. So in mathematical point of view, we'll say that we want to achieve the CPSS, optimum drug concentration, or the steady state concentration, with one bolus shot. So for this, we have CP is equal to CPSS, or I must say CP1 is equal to CPSS. It means CP1 max is equal to CPSS max, and so the CP1 minima is equal to CPSS minimum. The value of CP1 max is equal to CP naught, and CPSS maximum is equal to CP naught into 1 over 1 minus E minus K tau, where tau is the dosing interval. Clear? Here is the CP naught. Now we have to cancel, but before cancelling, let me tell you that CPSS maximum, we know one thing, that concentration of the drug is equal to dose of the drug divided by volume of distribution, dose over VD. So in case of CP naught, it will be DL, means the loading dose. The first dose is always a loading dose, so it is DL over V. And CP naught, in case of CPSS maximum, it will be maintenance dose. that we have to maintain to achieve the therapeutic effect divided by V or VD into 1 over 1 minus E minus K tau. So we have this scenario and we have to cancel the equal terms, that is V and V. So dl over dm is equal to 1 over 1 minus ek tau. This is actually equal to accumulation of the drug, accumulation factor or accumulation. It will tell us about the accumulation of the drug, that how much or to which extent drug should be accumulated or is accumulated. Clear? Now, if we say that dosing interval tau is equal to half life of the drug, tau is equal to t half, then what will happen to this equation? So actually k is equal to 0.693 over t half. And I have to tell you one more thing, that n is equal to tau over t half. Okay, so we have a scenario in which dosing interval is equal to half life of the drug, and we have put the value of the k, that is 0.693 over t half here. Tau over t half is equal to n, so we will put this as n. Now tau over t half means n will be equal to 1. And n is equal to 1, then what will happen? dl over dm is equal to 1 over 1 minus e minus 0.693. And when you solve this, we will get 1 over 1 minus 0.5. And when you solve this and this, we will get 2. So what does it mean? So dl over dm is equal to 2. It means dl is equal to 2 dm. So 2 maintenance doses will make 1 loading dose when we put the half-life equal to the dose interval. In case of paracetamol, half-life is 2 to 4 hours. But taking the medication after every 2 hours is difficult. So we set the dosing interval to 6 hours and set the dose of the paracetamol as 1000 milligram. So that is why the loading dose and maintenance dose of the paracetamol are almost same. But in case of vancomycin, half-life is 6 to 9 hours and its dosing interval tau is equal to 8 to 12 hours. So these two times are actually about same. Okay, so when we will make the t half and tau same, say for example 8 hours and 8 hours half-life and 8 hours of the dosing interval, we can put t half and tau of the vancomycin equal and we will get this result. So that is why some of the drugs whose dosing interval is equal to the half-life, in order to get the CPSS within a single shot, we have the loading dose equal to the double of the maintenance dose.